Hi, this is javinkharod, a chemical engineer by profession, going to continue our today's topic, green hydrogen. Now, what is that? Green hydrogen is hydrogen produced by electrolysis of water using recoverable electricity. Production of green hydrogen causes significantly lower greenhouse gas emission than production grey hydrogen, which is derived from fossil fuel without carbon capture. Green hydrogen principle purpose is help to limit global warming up to 1.5 degrees centigrade, reduces fossil fuel dependence by replacing grey hydrogen, and provide an extended set of end causes specific economic sector, subsector, activity, the end use may technically difficult decarbonize through other means such as electrification with renewable power. The main applications are likely to be heavy industries, high temperature process alongside electricity, feedstock for production, green ammonia, organic chemical and alternative derived coke, steam making and long haul transport, shipping, aviation and the lesser extent heavy good vehicle and long term energy storage. Now definition. Most greenhouse hydrogen is defined hydrogen produced by the electrolysis of water using renewable electricity. This is the green hydrogen used for many precise definition sometimes add to the criteria the global greenhouse hydrogen standard define green hydrogen as hydrogen produced through electrolysis of water with 100% or near 100% renewable energy with close to zero greenhouse gas emission. The border less use definition greenhouse hydrogen is also include hydrogen produced through various other methods that produce relative low emission and meet other sustainability criteria. For example, production method may involve nuclear energy or biomass feedstock. Now, its uses. The potential for green hydrogen plays significant role decarbonizing energy system where there are challenges and limitations replacing fossil fuel with direct use electricity. Now, hydrogen fuel can produce intense heat required for industrial production of steel, cement, glass, chemical, contributing decarbonization of industries alongside other technology such as electric, arc furnace, or steel making, however likely to play a larger role providing industrial feedstock, the cleaner production ammonia and organic chemical. For example, steel making, hydrogen could function to clean energy carrier and also lower carbon catalyst replacing coal derived coke. Hydrogen use decarbonize transportation likely to find largest application shipping, aviation, larger extent heavy good vehicle through use hydrogen derived synthetic fuel such as ammonia, methanol, fuel cell technology, energy resources, hydrogen, superior energy density 39.6 kilowatt hour versus lithium battery 0.15 to 0.25 kilowatt hour for light duty vehicle including passenger car. Hydrogen is far behind other alternative fuel vehicle, especially compared the rate of adaptation and absorption of battery electric vehicle may not play significant role in future. Now, green hydrogen can be used for long duration grid energy storage and for long duration seasonal energy storage. It has been explored alternative batteries short duration energy storage. Now regulation and standard. In European Union, certificate renewable hydrogen defined the produce from the non-biological feedstock required emission reduction is 70% below the fossil fuel intended to replace its strict Europe low carbon and which define made using fossil fuel feedstock core certificate, lower hydrogen must achieve at least 70% reduction emission compared with green hydrogen it replaces. Now, what is green hydrogen? How does it differ from traditional emission, incentive, grey hydrogen and blue hydrogen? Now, hydrogen is simplest and smallest element in the periodic table, no matter how it is produced and the same carbon-free molecule, however, pathway to produce very diverse and so emission greenhouse gases like carbon dioxide, methane, green hydrogen defined hydrogen produced by splitting water into hydrogen, oxygen using renewable electricity. This is very different pathway compared to grey hydrogen and blue. Green hydrogen is traditionally produced methane split steam into carbon dioxide and mined for climate change, and hydrogen, grey hydrogen, has increasingly been produced also from coal with significant higher carbon dioxide emission per unit hydrogen produced, much that it is often called brown and black hydrogen. Instant grey, it is produced industrial scale today with associated Amazon compare the combined Amazon, Indonesia, UK, it has no energy transmission value, quite the opposite. Now, blue hydrogen follow same process as grey with the additional technology necessary to capture CO2 produced when hydrogen split from methane or from coal. The store is long term, it is not one color rather than very broad gradation. Now 100% of the CO2 produced can be captured. Not all means storing equally effective long term. The main point capturing large part of carbon dioxide. The climate impact hydrogen production can be reduced significantly. There are technology, methane pyrolysis and hold promises for the higher capture rate and effective long-term storage. Carbon dioxide solid form potentially so much better than that diverse and deserve their one color in the hydrogen taxonomy rainbow. Turquoise hydrogen, however, methane pyrolysis is still pilot stage when green hydrogen rapidly scaling up based on 2K technology, renewable power, particular solar and wind, but not only electrolysis. Unlike renewable power, which is cheapest sources of electricity in most countries, region today, electrolysis, green hydrogen production lead to significantly scale up, reduce least 3 times other next decade. And however, the methane pyrolysis electrolysis is commercially available and produce multiple international supply right of green high energy solution. What are the merits of the energy transmission solution toward the green hydrogen economy? How would you transitions of the green hydrogen economy where we are currently with grey energy and grey hydrogen? Grey hydrogen is important pieces energy transmission. This is also next immediate step. We first need further accelerate the development of renewable electricity, decarbonize existing power system, accelerate electrification of the energy sector, larger, lower cost renewable electricity, finally decarbonize sector, difficult electrify, heavy industry shipping, aviation through green hydrogen. Now it is important today produce significant amount grey hydrogen, carbon dioxide, emission priority will be start decarbonization, existing hydrogen compound, example replacing ammonia from natural gas with green ammonia. Recent study and debate about concept of hydrogen as transmission fuel, still green hydrogen become cost competitive. Now next, how would green hydrogen become comparatively wise blue hydrogen? What sort of strategic investment need occur technology development process? The first step provides significant blue hydrogen replace grey without price emitting carbon dioxide. There are business and gases company invest complex, costly carbon capture system and geological storage of carbon dioxide. Once framework, such lower carbon hydrogen, green, turquoise, and is comparatively grey hydrogen. Question should arise: invest in this risk of have standard asset. How soon will greenhouse become cheaper than the blue? The answer will be course different depending on region. The net zero world and objective more and more country community the remaining emission from blue hydrogen would have to be offset negative emission. This will come cost parallel gas price has been very volatile lately leveling blue hydrogen price highly correlate the gas price expose CO2 price uncertainty but how natural gas price volatility for green hydrogen however might witness. Similarly, the non-incentive and there are we need to reduce investment cost as well as cost of investment through scaling up manufacturing, renewable technology and electrolysis while creating lower risk of tax reduces cost capital for green hydrogen investment will lead stable decreasing cost. Green hydrogen will oppose volatile potentially increases cost blue hydrogen. Renewable energy technology reach a level of maturity already today. They allow competitive renewable electricity generation from all around the world. Prerequisite for competitive green hydrogen production electrolysis through they are still developed a very small scale depending scale up 3 order of the magnitude in the next 3 decades reduce their cost threshold. Several governments has now included hydrogen fuel technology in their national strategy given rising demand, transmission toward decarbonization of economy, enabling technology, higher carbon capture rate, and they would be advised policymakers, decision makers, and they evaluating the pro and cons of green hydrogen. Now, the green hydrogen reach zero emission, particularly for industry, shipping, aviation. However, we need most urgently energy efficiency, electrification, and acceleration growth, renewable power generation. Now, once this is achieved, 40% demand of the decarbonized and there we need green hydrogen, modern bioenergy, and direct use of the renewable. Once we further scale up renewable power, decarbonize electricity, we need position, further expand renewable power capacity, reduces competitive green hydrogen and decarbonize hard abate the sector minimum extra cost. The future about green hydrogen. Now opportunity for rapid uptake green hydrogen. Next decade, hydrogen demand already exists. Decarbonization, ammonia, iron, and other existing commodities. Many industrial presence, they are hydrogen, can replace grey and green, blue, provide CO2, adequately price, other mechanism for decarbonization sector put in a place. Now aviation and situation slight different. Drop in fuel based on green hydrogen but essential identification of jet fuel methanol produced from oil and their existing plant. See minimal no adjustment. However, fuel contains carbon dioxide which has captured somewhere and add hydrogen. Release again during combustion. This reduces but does not solve problem carbon dioxide emission. Synthetic fuel can deploy before 2030 and right incentive are in place justify extra cost, reduce the emission. In the coming year, ship can switch green ammonia, a fuel produced from the green hydrogen and nitrogen from air does not contain carbon dioxide, but investment will be needed. Replace engine, tank, green ammonia, currently much more expensive than fuel oil, hydrogen plant are further away. this will be essentially new plant have designed, built and sold airlines replace existing jet fuel power plant clearly, now feasibly in 2030. In this sense, green jet fuel produced with combustion, green hydrogen and sustainable bioenergy is a solution can be deployed near term. Now, conclusion. The main action accelerate decarbonization between now and 2030 are energy efficiency, electrification of renewable, rapid acceleration of renewable power generation, which will be further reduce already lower cost renewable electricity, scale up sustainable modern bioenergy needed, among other, produce green fuel, require carbon dioxide, decarbonization of grey hydrogen and green hydrogen, which would bring scale, reduces the cost electricity, making green hydrogen competitive, ready the further scale up 2030 toward objective reaching zero emission by 2050. What are grey hydrogen problem in planet? According data International Energy, some of the 70 million ton hydrogen are currently consumed worldwide. The problem, almost all hydrogen produced from coal and natural gas, they are obtained by most polluting technique in planet. Less than 1% of the world production, the hydrogen-based water electrolysis power, renewable energy, only 0.1% hydrogen consumed as a green. To give the idea what means production, grey hydrogen emit 830 million tons of carbon dioxide per year. Annual carbon dioxide emitted by economical Indonesia and United Kingdom combined, put another way, generating hydrogen equivalent pollution created by two countries, total more 300 million inhabitants. Given this alternating and alarming data, vital understand origin of hydrogen. Green hydrogen can be universal tool to replace production model that contribute climate change. It helps decarbonization, energy conservation that is more resistance, electrification such as heavy industries, long haul transport. How does green hydrogen work? When we need to burn energy, hydrogen stored specific tank challenges into channel and fuel cell. This is the line again with oxygen from air and electricity obtained only by product, the process of water, resulting clean, sustainable system, the zero carbon dioxide emitted to produce energy. Now benefit of green hydrogen fuel. Green hydrogen are benefit such as it is clear energy. Only waste is generated is water. It is renewable energy. It uses natural resources. They are not executed. It is storable. Green hydrogen can be compressed, stored, hooked time and long time. It is transferable because it is very light element compared hydrogen tank, allow easier handling than lithium batteries because they are lighter, which facilitate transport as a result. Okay guys, this is up to our today's topic, green hydrogen. I hope you get sufficient knowledge after watching this video. Next Sunday, we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.